Today we're going to talk about calculating surface area and volumes for prisms. And so first thing we're going to do here is we're going to start off by just talking about what a prism is. So it's a three-dimensional solid, like we've been talking about the last couple days. Basically what it is a bunch of rectangles wrapped around some type of polygon. So like in this case, we have these hexagons on the top and bottom of our figure. And then we have a bunch of rectangles connecting them all the way around, okay? So the bases are the first thing we talk about. Those are the two shapes that are directly across from each other. They're identical to each other, so same exact size and shape. And like I said, then they're wrapped with rectangles. So we have rectangles wrapped around the entire outside then. So they're always opposite from each other. And as far as like the formulas and stuff that we're going to talk about today, it's going to be really important that we can identify those bases because those are the pieces we need specifically for a lot of the calculations that we have. And so when we're looking through these, those bases can be hexagons, they can be rectangles, they can be triangles. So any shape could be a base. So we just got to have kind of look real closely at the picture and identify, okay, what are the two identical pieces across from each other? And then kind of work from there. So like in this first example here, we talk about surface area. And for surface area, there's two ways we can do this. And so we're going to start with the long way. So we actually kind of go face by face. So pick every single face in the figure and calculate the area and then add it all together. So for instance, if I'm looking at this figure here, okay, I can break it down. There's 6 different faces that I would have to calculate. So I've got the front face. That's this rectangle right in front here. So I could calculate its area. Since it's a rectangle, that means base times height. So base 14 centimeters, height 6 centimeters. So I could calculate that, and I would get 84 square centimeters. The back side would be directly across from it. They're going to be identical in shape and size. So I'm going to get the same exact area for the back side. So 84 square centimeters. Then I have to pick 2 other sides. So then I can go to the right side, for instance. And so if I look at the right side, so now another rectangle over here, again, kind of the same thing, base times height. So we do our 4 times 6, we get 24 square centimeters. The left side has to be identical, so it's gonna be the same thing. And then we finally finish it off with the last 2 figures, or the last 2 sides, top and bottom. So on the top and bottom, if I highlight the top up here, so the top has the same length as the bottom piece, so 14 centimeters across, and then 4 centimeters from front to back here. So we take our 14 times 4, and we get our 56 square centimeters. Bottom must be the same size, so 56 square centimeters. And then after I've calculated all of those things, I can go ahead and add them all together. So if I take the 84 plus the 84 plus the 24 plus the 24 plus the 56 plus the 56, I get a total surface area of 328 square centimeters. So that's a possibility for every prism. You could break it down by every single face, find the area of every single one, and then add them all together at the end. However, if you notice there, that process kind of takes a little bit of time. And if you're doing like 15 of these on a homework assignment or on a test or something like that, it's going to take you a long time to get through it. So a shorter method is using those bases like we talked about a little bit ago and having a formula set up to calculate the different areas all at once. So the 2 things we're going to talk about here are going to be what we call lateral area. So this formula right here. Okay, so the P, as it states down here, stands for perimeter of the base. The H is the height of the prism. Now, this is important to note that the height of the prism doesn't always mean from top to bottom. When we talk about the height of the prism, we're talking about one base to the other. So that's where identifying those bases is really important, is the height of the prism goes from one to the other. Sometimes it's top to bottom, but sometimes it's front to back or side to side. So it's really important that we understand base to base is that height. So as far as the picture here then, you can see that in this prism, I kind of went ahead and highlighted the base is in red, this triangle on top here, and this triangle on the bottom. So I highlighted those with a different color to kind of make those stand out. So the first thing we would do for this lateral area is we would add up all 3 sides of the triangle. So we see the 11.3 up here. Now these 8 inches down here on the bottom mean that the sides on the top are the same size. The bases are always exactly the same measurements. So basically I'm going to have my 11.3 plus 8 plus 8. So that gives me a perimeter of 27.3 inches. And then I multiply by the height of the prism from base to base. So from triangle to triangle over here gives me the height of my prism. So that's going to be my H. So I take that 27.3 times the 7, I get 191.1 square inches. So that first step, that lateral area, identify the base, add up all the sides, find that perimeter, and then multiply by the height of the prism from one base to the other. Now the next one then we look at is total surface area. So now if I want to put everything together, so I don't want to sit there and go face by face by face and add everything together. Now I'm going to kind of put all this together here. So for total surface area, the pH is what we already solved for. We already found that lateral area in the previous step, so that's that 191.1. So as I go to fill in my formula here, I've already calculated the 191.1 plus 2 times now the area of the base. This piece right here, this capital B, as it states down below, that's the area of the base. So this is something we can calculate within the formula itself, but what I will typically do is I will calculate that as a separate piece. So like off to the side here, I would say, okay, the area of my base, since we're talking about the triangles here, so for a triangle, it's base times height divided by 2 is my formula that we discussed the previous week with our areas. So my base, 8, and my height, 8, get plugged into the formula. So I have 8 times 8 divided by 2, and the area of my base then comes out to be 32 square inches. So once I have that area of the base, I take that number and I plug it into my formula. So I'm going to take the 2 times the 32 here, and then I add it all together. So 191.1 plus 2 times 32, and we get a total surface area of 223.1 square inches. So anytime we're doing this surface area formula, okay, they might ask for lateral, they might ask for total surface area. So it's all about finding the perimeter of the base, recognizing the height from base to base, and then calculating the area of the base and then putting it all together. So if we look at another example here, this time they changed the shape of the bases on us. So this time we're talking trapezoids. So we've got this trapezoid in front as one of my bases, and then we have this trapezoid in back as my second base. So those are the 2 bases, and so if we're talking lateral area and surface area here, we're using the formulas from that previous slide. So the first thing I'm going to do is I'm going to calculate some of the pieces that I need. So the perimeter is going to be adding up the 4 sides of the trapezoid. So I've got this outside, I've got the 12 centimeters in the back here, the 9 centimeters, and then the 8 centimeters. If I go all the way around the trapezoid, those are my 4 pieces. So if I add those together, okay, we end up with a perimeter of 36. So there's the perimeter that I need for my lateral area formula. The height of my prism, so I'm going to use a different color here. The height of my prism goes from base to base, so from trapezoid to trapezoid. So if I highlight that piece here, from trapezoid to trapezoid, that tells me that the height of my prism is 10 centimeters. So I have 10 centimeters there, and I've got the perimeter of 36 centimeters. The other thing I know I'm going to need is the area of my base. So I'm going to need that capital B to be calculated as well. So for a trapezoid, just as a reminder, that formula was the height of the trapezoid times base 1 plus base 2, and then divided by 2. So that's a formula we discussed a previous week here, and now we're going to be using it to kind of help us with these surface area and volume formulas. So area of the base, we plug in the value. So for my trapezoid, the height goes from top to bottom here, so the height is 6 centimeters, times, if I add the 2 bases together, so the 8 and the 12, gives me 20, and then if I multiply those and divide by 2, I get an area of 60 square centimeters. So I've got all three pieces that I need for my formula now. So as far as lateral area, it says take the perimeter, 36, times the height of the prism, 10. And so we get 360 square centimeters for the lateral area. Then if I want total surface area, we take that lateral area, so the 360, plus 2 times the area of the base, so 2 times the 60 that we found earlier. And so then if I put that all together, we get a total surface area of 480 square centimeters. So as you're working through these problems here, the kind of steps that I would take is I would recognize kind of where the bases are, so kind of highlight those and figure out, okay, there are the bases. And then I would do my 3 calculations just right off the bat. Find the perimeter, find the height of the prism, find the area of the base, and then all I have to do is whatever they ask for in the problem, all I got to do is plug it into the right formula, put it in my calculator, and get my answer. So that's kind of the way I would attack those problems. Now as we switch gears to volume then. So for the volume of a prism, we kind of have it worked out here. The formula is the first thing we want to take note of. So that formula for the volume is the area of the base again. So that's going to be a pretty key piece. We're always looking for those bases. So area of the base times the height of the prism. Again, you might want to remind yourself this is from base to base. It does not mean like top to bottom like height usually is. So from one base to the other. So in this case, we identify our bases. So in this example that we have worked out here, I chose to use this right side and therefore the left side on the other side. If we kind of imagine this left side back here, we're using those 2 pieces as our bases. So as far as the area of the base, since it's a rectangle, we did base times height, so 4 times 6. Then the formula calls for the height of the prism, so that's the 14 from one base to the other. Again, it doesn't go top to bottom, it's from base to base, so 14 centimeters. And so then if we multiply all 3 together, we get our total volume of 336 cubic centimeters. That's the other thing to note here. Our units change because now we're doing volume, which is cubed. So, kind of like we did with surface area, the thing I would suggest doing is I would go ahead and calculate the area of your base. I would identify the height of the prism and then just put them together in the formula. So if we look at like these couple examples here. So on these couple examples, if I look at this first rectangular prism here on the left, if I want to calculate that volume, I'm going to pick 2 sides. So 2 of the opposite sides to be my base. So in this case, I usually kind of try to pick the odd shape out. So like I would pick the top as one base, which means then the bottom would be my other base. And so the first thing I'm going to do is I'm going to calculate that area. So for the area of my base, since it's a rectangle, just base times height. So I'm going to take 5 times 4, gives me 20 square meters. The height of my prism then, from base to base, so from square to square here, or from rectangle to rectangle, would be 2 meters. And then now I'm just going to plug it in the formula. So for the volume, the area of my base was 20, times the height of my prism is 2, I get 40 cubic meters. Okay, so that's kind of what I would suggest as far as the process for this type of problem. So when we look at the second one, first thing, there's a piece missing here from the picture. So this side is 7.5 inches, and so now we have all the dimensions that we need. So again, as we're talking volume, I need the area of my base. So as far as the area of my base, it's a triangle, so base times height divided by 2. So as far as finding the pieces that I need, I look for that right angle in the triangle. That means I have my base and my height here. And so using the dimensions from above, my base 7.5, my height 10 inches, I plug those into the formula. So I've got 10 times 7.5 divided by 2, and that's going to give me an area of 37.5 square inches. So that's the first thing I need, is that area of the base. Then I need the height of my prism, and again, the height is from base to base. So from triangle to triangle here, I get the height of my prism is 8 inches. So then when I put it all together, the volume of my triangular prism would be the 37.5 from the area of my base times the height of my prism 8, and that gives me a total volume of 300 inches cubed. So making sure you know the formulas, making sure you know how to plug in the pieces. So just calculate each piece that you need, plug it into the formula, put it in your calculator, and go ahead and get your answer from there. And so with that, you should be able to work through the homework, the worksheet for today. So it's going to have a bunch of the same types of problems. You have rectangular, triangular, trapezoidal prisms, finding surface areas, finding volumes. And so just working with those formulas and trying to get some practice with that.